Hello everyone. Welcome to today's lecture on function basics. Definition, domain, range and graph. Function. Function is a tool to describe the real world in mathematical terms. Basically, function describes relations in the real world. For example, boiling temperature of water depends on elevation above sea level. At Mumbai, which is at sea level, means elevation is 0 meter, water boils at 100 degrees Celsius. At Leh, which is more than 3500 meters above sea level, water boils at 90 degrees Celsius. And on Mount Everest, which is nearly 9000 meters high, water boils only at 71 degrees Celsius. Here, boiling temperature depends on height. Hence, we can say boiling temperature is a function of elevation above sea level. Another example is interest on cash investment depends on how long you keep the money invested. With a 5% annual interest rate on 100 rupees, we get 5 rupees on 100 after 1 year. But after 2 years, it becomes 10.25, and after 3 years, it is 15.76. Here, interest depends on length of time. We can say interest is a function of length of time. Similarly, area of a circle depends on its radius. As we know that A equal to pi r square, where A is the area and r denotes the radius. So if R is 1, then area is 3.14. For R equal to 2, area is 12.57. For R equal to 3, area is 28.27. So again we can say area is a function of radius. So in real world, one variable quantity, say y, depends on other variable quantity, say x. Symbolically, we can write y equal to f of x. Here x is called independent variable because we choose its values freely. Y is called dependent variable because values of y depends on values of x. Definition of a function. Mathematically, a function f from a set D to a set y is a rule that assigns a unique element of y to each element of D. Here, both sets D and Y are the subsets of set of real numbers R. D is called domain, Y is called codomain. To understand functions better, look at some mapping diagrams. In first diagram, the domain element x1 has unique image y1. Domain element x2 has unique image y2. So here each element of domain has unique image. So this is a function. In second diagram, the element x1 has image y1. The element x2 also has the same image y1. So in this diagram you see each element of domain has unique image. So this is also a function. In third diagram, the element x1 has unique image y1, but element x2 has no image. So this is not a function because definition of function says that each element of domain must have unique image, but x2 has no image here, so this is not a function. In fourth diagram, domain element x1 has image y1. Domain element x1 also has other image y2. So element x1 has two images. y1 and y2. That breaks the uniqueness condition, so this is not a function. Let me give a couple of examples also. If y equal to 2x plus 3, so 4x equal to 1, value of y is 5, 4x equal to 2, value of y is 7. So here each x has exactly one y, so this is a function. Second example, if y square equal to x, this implies that y equal to plus minus root x. So 4x equal to 4. There are two values of y equal to plus 2 and y equal to minus 2. So here 4x equal to 4, we are getting two values of y, 2 and minus 2. So again, here I can say that uniqueness fails, means not a function. If we draw the diagram, if we draw y square equal to x, you see that y square equal to x is this one, and vertical line. Then you see here that 4x equal to 4. We have two corresponding values, one is 2, one is minus 2. So from this diagram you can see that x equal to 4 has two corresponding values of y, 2 and minus 2. So this is not a function. Now important question is, for what values of x function is valid? This leads concept of domain and range. So domain is the largest set of input values x for which function is mathematically defined. We can say domain has all allowed values of x. Range is the set of all images f of x for all x belongs to domain D. So range is the collection of all possible outputs, and we can define range equal to f of x set of f of x values for all x belongs to D, and definitely it is a subset of y. For example, look at the diagram here. In this diagram, you see domain elements are x1, x2, x3 and x4. Codomain elements are y1, y2, y3, y4. So this is the set codomain. Now what is the range? Range is the set of all images. So y1 is the image of x1, y2 is the image of x2, y4 is the image of x4, but y3 is not the image of any element of domain D. Okay, so range will be set of y1, y2 and y4. So clearly we can see range is a subset of codomain. So we can write range is a subset of codomain Y. So whenever we deal with functions, identifying the domain and range is one of the most important steps. So to identify domain, try to find domain restrictions, means restrictions on x values. Restrictions on x values means the values of x for which function is not defined. Okay, so some of the restrictions may be, if we write that denominator should be not equal to 0. For a square root function to be well defined, the expression inside must be non-negative. So we can write here that inside square root, expression inside square root must be non-negative. And if we talk about logarithmic function, so inside logarithmic, it should be greater than 0. Now, what is graph? Graph of a function with domain D is defined as set of points x, f of x, where x is the domain value and f of x is the image of x by function f. Let's see an example. Graph of the function y equal to x square over interval minus 2, 2, means domain of this function is minus 2, 2. So to draw a graph, take some discrete values of x. Discrete values of x we consider here 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4. And we find corresponding values of y. For x equal to 0, value is 0. For x equal to plus minus 1, value of y is 1. For plus minus 2, it is 4, then 9, then 16. So here we are getting a set of points, you see 0, 0, 1, 1, minus 1, 1, 2, 4, minus 2, 4, and so on. Based on this set of values x, y, we draw the graph. So this is the graph. You see here, this point is 1, 1, and this point is minus 1, 1. Same, this is 0, 0. Other point 2, 4. This is 2, 4, and this is minus 2, 4. So using these set of points, we draw a graph. Some important points about graph are: graph of a function is the picture of its behavior. Graph gives immediate idea about growth. Growth means whether the function is increasing, decreasing, or constant. Symmetry means that whether the function is symmetric about y-axis, whether function is symmetric about origin, or it is not symmetric at all. Graph tells about the limits of function also. It shows what happens when x tends to infinity or x approaches to a critical point or any other value. Every curve cannot be a graph, but every graph is a curve. Why? Because definition of function says that one input gives one output, and this is checked by vertical line test, which is if any vertical line cuts the curve at more than one point, then it is not a graph. If I draw a simple curve, see this one, and I check that it is a graph or not, so I draw a vertical line, and this vertical line cuts the curve at 3 points. So it is not a graph, it is a curve. So one example, the set x comma y such that x square plus y square equal to 1, this set represents a curve, not a graph. So first we mathematically simplified this function. So x square plus y square equal to 1, this is given. So we can write y square equal to 1 minus x square. Taking root, we write y equal to plus minus square root 1 minus x square. So from here we see that y has two values. One is positive, one is negative. So we will get two values of y corresponding to 1x. So I can say this is not a function. This is a relation. This is a relation. The given set x square plus 1, the picture, if we draw the picture of x square plus y square equal to 1, then it represents a circle you see here. So this circle represents a curve or a graph. So we draw a vertical line here, and we see that this vertical line cuts the circle at 2 points. That is corresponding to one value of x, we are getting two values of y. So this is a curve, not a graph. But this function y equal to plus minus root 1 minus x square, this function represents two functions. One is y1 equal to 1 minus x square, and other is y2 is minus root 1 minus x square. So both are functions. If we draw curve corresponding to these two functions, then we see one curve is, this is y1 equal to root 1 minus x square. So we can apply vertical line test here also. So if we draw a vertical line, it cuts at 1 point. So means corresponding to any x value, we are getting one value. For other function, curve is this one. So here again, you see, if we draw a vertical line, then corresponding to this x, we are getting unique value of y2. So now I can say that this is a graph. This is also a graph. This graph is corresponding to this function, and this graph is corresponding to function y2. y2 is minus root 1 minus x square.